Hello and welcome back to Every Problem. This is Stewart Calculus 8th edition, section 1.1, problem 37. In this problem set, they're asking us to find the domain of the function. So we have f of p equals the square root of 2 minus the square root of p. And this function's a little bit interesting because, right, we have the double square root there in a way. But that's okay. It's not quite as complicated as it looks. We just need to break it down to more simple components. So let's write this again. We have f of p equals the square root of 2 minus the square root of p. And what we need to know is what input values that we can have that will give us some output. That's what the domain is what can we put into the function and get some normal output. Well, what do we know about square roots in general? We know that square roots need to have positive numbers. So we know that 2 minus, well, a square root can also have 0, right? So 2 minus square root of p must be greater than equal to 0, right? Because if 2 minus the square root of p is less than 0, then what will happen is we'll have a negative under that radical, and then we'll run into trouble. So in order for 2 minus p to be greater than or equal to 0, let's figure out what makes it 0. So 2 minus root p equals 0, right? So we'll add root p over. And then we'll get 2 equals the square root of p. We'll square both sides to get rid of that square root. And that will leave us with 4 being equal to p. So we know that, now we know that p cannot be greater than 4. So that's good. 4 is the maximum value of p. But also p has a minimum value because we see here, back at the top of the page, right, that p itself is under a square root. So p can't be a negative number either. So it can go as low as 0, but no further. And with that, we know that p has to be less than 4. So we'll say p less than 4 and p greater than equal to 0. And now we have enough to say what our domain is for the function. So for our answer, we'll write domain, and that's going to be equal to a closed bracket starting at 0, because it's completely fine for p to equal 0. If you have a 0 under a square root, it'll just be 0. And then up to, let's see. Oh, well, it can equal, sorry, I should have, I made a little mistake there. It can be, p cannot be greater than 4, but it can be equal to 4. So just double checking everything really quick to make sure I'm not misguiding or anything. Yeah, it looks like p can be from 0 up to 4 and including 4. So we'll have closed brackets on both sides. Sorry about that. But yeah, that's going to be our answer, is 0 up to and including 4. Thank you.